Good morning, children. Children, as we are revising the refraction of light at plane surfaces, as a part of the refraction of light at plane surfaces, we learned a few points, children. Okay, that is, we revised few of the points. That is Snell's law. Snell's law states that n1 sin I is equal to n2 sin r. Okay, Snell's law states that n1 sin I is equal to n2 sin r, whereas n, that is the refractive index, is inversely proportional to its velocity, children. Okay, when the velocity is increased, the refractive index decreases, and the refractive index increases when the velocity decreases, children. Okay, therefore, as we covered all the points whatever that are there in this chapter, children, next we go with the laws of motion. We revise the chapter called as the laws of motion, children. Okay, laws of motion. In the chapter laws of motion, children, in the chapter laws of motion, first we go with the Newton's laws of motion, or Galileo's concept of motion. Galileo concept of motion. First, Aristotle is the person who said that any body which is in the state of motion comes to rest after some time. Okay. By overcoming the statement which is given by the Aristotle, Galileo said that any object which is in the state of rest or state of motion continues to be in the same state until some forces, external forces, acted upon it. Okay, that is the statement that was given by the Galileo, children. Okay, Galileo. And here the same concept was carried on by the Newton, who is a student of the Galileo. Okay, the same concept was proposed by the Newton also. Okay, and here Newton, he proposed, okay, Newton proposed three laws. Newton proposed three laws. Okay, we call it as Newton's laws of motion. Newton's laws of motion. Newton proposed the three laws which we call it as Newton's laws of motion. That is, the first one is Newton's first law. Newton's first law. Okay, Newton's first law states that any object which is in the state of rest or state of motion continues to be in the same state until some external force acts upon it. Okay. Okay, children. Newton's first law states that any object which is in the state of rest or which is in the state of motion continues to be in the same state until some external force acts upon it. And here we come across a word called as inertia in this Newton's first law, children. We come across a word called as the inertia in the Newton's first law. Okay. Inertia. Okay. Newton's first law is also called as the law of inertia. Inertia. It is the resistance of a body to change its state from one form to the another form. It is a resistance of a body to change its state from one form to another form is called as the what? Inertia. Okay, children. And here Newton's first law is also called as the law of inertia. Law of inertia. Newton's first law is also called as the law of inertia. Okay. And here this law of inertia is divided into three types, children. That is inertia of rest, inertia of rest, inertia of motion, inertia of motion, and inertia of direction. Inertia of direction. Here the law of inertia is divided into three types. Okay, that is the inertia of rest, inertia of motion, and inertia of direction, children. Okay, inertia of rest, inertia of motion, and inertia of direction. Okay, and here we learn about what is inertia of rest. Okay, the resistance of a body to change its state of rest to the motion. Okay, it is a tendency, or we can define it as the tendency of a body which is in the state of rest continues to be in the same state until some external force acts upon it. Okay, or the resistance of a body to change its state of rest to the motion, to change its state of rest to the motion, is called as the inertia of the rest. Okay, the example for the inertia of the rest, children. Okay, here normally when we flick a carom board coin, when we flick a carom board coin, when we hit a carom board coin, okay, normally the stack of coins will not be displaced. Okay, they will be in the same position. That is an example for the inertia of rest, children. Okay, normally when we are playing the carom board, okay, when we flick the coin, that means when we pull the coin very fastly, okay, when we pull the coin fastly, the stack of coins will be in the same position. They will not get disturbed. That is because due to of the inertia of the rest. Okay, and in the same way, a placing of a coin on a cardboard of which is placed on the water, on the glass. When you flick the coin, the cardboard, okay, the coin will be falling into the water, children, or into the glass, but whereas it won't comes outside as we pull it. That is because due to of the inertia of the rest. The trees shed their leaves when the fast blowing wind blows. The trees shed their leaves when the fast blowing wind blows. That is due to the inertia of the rest. Okay, and in the same way, a person falls backward when a vehicle starts suddenly. Okay, when a vehicle starts suddenly, a person falls backward. It is because due to the inertia of the rest, children. It is due to the inertia of the rest. Okay, and here when we beat the carpet, when you beat the carpet, the dust comes outside from the carpet. Or when you beat the beds, okay, that means the cushions of the beds, okay, with a stick, the dust comes outside. Why the dust comes outside? It is due to the inertia of the rest. Actually, it won't. That means to overcome the resistance, to change its state from the rest to the motion. When when the carpet is at rest, the dust will be inside the carpet. But when we beat, we are setting the carpet into the state of motion. As a result, what happens? The dust comes outside, children. Okay. Therefore, here, okay, those are the examples of the inertia of the rest. Okay, children. And here, why a person falls backward? Why a person falls backward when the vehicle starts suddenly? Okay, a person falls backward when the vehicle starts suddenly. It is due to, okay, it is because here our total body is divided into two parts. Total body is divided into two parts, children. That is the upper part as well as the lower part. Upper part as well as the lower part. Okay, children. And here the upper part will not be changing. If it is in the state of rest, it will be in the same state of rest. If it is in the state of motion, it will be in the same state of motion, children. Okay, the upper part will not be changing, only the down part will be changing. Okay, only the down part will be changing. Therefore, here when a body is in at rest, when a vehicle is at rest, our total body also will be in the same state of rest. That is the upper part as well as the lower part. But when the vehicle starts suddenly, when the vehicle starts suddenly, the down part will be changing with the vehicle. Okay, the down part will be set into the motion, whereas the upper part will be in the same state of rest. As a result, what happens? We fall backward. The down part will be moving forward, whereas we fall backward. Okay, that is because due to of the inertia of the rest, children. Okay, that is the inertia of the rest. Okay, children. Okay, the remaining we'll be learning in the next class, children. Thank you. Have a nice day.